All right, welcome back to the next section in our distance learning environment for Algebra 2. We're going to continue on with logs today. We're going to be talking about solving some log equations. There's really going to be three cases that we're going to go through as we do this. So again, just as always, as I start off these things, good idea to have this paper and something to write with. As we go through some of these examples, there's just going to be examples today, nothing really, it's just maybe some algebra and figuring out how to do these things. But before we do that, let's start off with a little funny. I'll let you read this by yourself. And of course, if you couldn't tell by the picture, why do planes hate math? Because gives them square roots. If you don't laugh at that, come on now. You gotta give that a little chuckle at least. Anyway, so let's move on. So we're going to jump right in here. So the first case is if you have an equation where you have two logs that are equal to each other. Okay, as long as the bases are the same and they're going to be for us, all we need to do is just set the inside equal to each other and then solve the variable. Okay. So something looks like this. We got log of 4x minus 7 equals log 5. Notice they're both what we call common logs, which is base 10. So we don't even care about that. We can just set the insides equal to each other and then go from there. So we got 4x minus 7 equals 5. Everybody can do that. 4x equals 12, so x equals 3. And like we've been saying for the past few weeks, it's a good idea to check the answers to make sure it works out okay. So we can plug that in, did that kind of all at once here. But you can see at the end, you get log 5 equals log 5, which is fine. So that does indeed mean that x equals 3 is the answer. Okay, so again, if you have a log on both sides and nothing else, you just set the insides equal to each other and solve. So here's another one. So I'll let you guys do this if you want to pause the video real fast and see if you can solve this. We've got log base 6 of 2x minus 1 equals log base 6 of x minus 2. Go ahead and pause and see if you can work that out by yourself. Okay, so again, the bases are the same, so we set them equal to each other. So we've got 2x minus 1 equals x minus 2. And that's easy to do. And you can do this in one step, sure, by all means. So you got x equals -1. When we check that, though, and if you got that, awesome, you did it correctly. But if you check that, notice when we plug this in, both sides end up being a -3 on the inside and a -3, inside of both arguments, right? And whenever that happens, again, we call those inside the arguments. Anytime any argument, doesn't have to be both of them, if any one argument becomes negative, that is going to mean there are no solutions. Okay, so please keep that in mind also. You might want to jot that down. Anytime you're plugging it in, if the inside is equal to a negative number, there's going to be no solutions. Okay, so that's case 1. So let's look at case 2. What if you only have a single logarithm on one side or the other? What do you do then? Well, the first thing, we always need to make sure and isolate that log term. So make sure and get that log by itself. And then we're going to use the definition from last week. Right, there it is. You should remember that from last week. We're going to use the definition to rewrite it as an exponential and then solve it from there. Okay? So here's the next example. So you got log base 7 of 4x plus 9 equals 2. Notice the log term is already by itself. So we don't have to isolate anything, it's already done. All we have to do is just use the definition. So we got 7 squared is 49, of course. We got 4x plus 9 equals 49. And then again, just use your algebra skills to get x by itself, and you get x equals 10. And if you plug that in, comes out okay, comes out to be log base 7 of 49 equals 2, which again, is true. So that means x equals 10 is your final answer. Okay, let's do one more of those in this case. So again, here's another example. But notice this time we do have to isolate the log. So think to yourself real fast, or even pause the video. What are you going to do first to isolate the log, and then how are you going to solve that? Now, first of all, we got to subtract 1 and then divide by 2. So now our equation really is log base 3 of 4x minus 5 equals 3. Okay? So now we're going to use the definition. So we got 4x minus 5 equals 3 to the third power. We know 3 to the third is equal to 27. And then again, just continue solving for x. So x is equal to 8. Plug that in. And I went ahead and used the isolated term, and that's okay to do that. But then we end up getting log base 3 of 27 equals 3, which again, we know is true. So x equals 8 is our answer. Okay, so those are the kind of the two, what I call kind of the easier cases where you either use the definition or just set the two logs equal to each other. There is one more case though. What happens if we have more than one log on a side? Well, then we have to go back to the rules from last week, and I didn't rewrite these on here, but you have those from last week. We can condense into a single logarithm and then use the definition to solve. Okay, so I'm going to give you a couple of examples of this. So we have log of 2x plus 1 plus log 8 equals log 2. We know from last week that we can condense that left-hand side. So that's going to become log of 2x plus 1 times 8. Remember, whenever we're adding, we condense by multiplying, which then we can just distribute the inside to become 16x plus 8. So now we can use the definition, and remember, this is our common log. If you don't see the base is automatically 10. So that means 16x plus 8 is equal to 10 squared. And then just continue solving that. So 10 squared is 100. Subtract 8, divide by 16, so you got x equals 6. And we plug that in. And you see that it is true. And really, in this case, I probably should have used the original one, but I went ahead and used the condensed version, and that's okay in this case. So x is equal to 6. Now, on the next example, let's take a look at this one. So now we have a similar type of thing, but now we have subtracting logs. So remember from last week, how do we condense, if we have two logs being subtracted, how do we condense those? Well, we have to use the quotient rule, right? So this is going to become log base 2 of 3x minus 1 over x equals log base 2 of 17. But remember, this is like our first case now. Now we have a log on both sides, so now we set it equal to each other. So we can have 3x minus 1 over x equals 17. Multiply both sides by x. We gather like terms and then divide. So we got x equals negative 1 over 14. But look what happens if you plug that in, and notice I am going to plug this into the original equation this time. So if I plug that in, notice my argument, at least on the second one, it turns out to be in both. My argument here comes out to be negative. As soon as that happens, you don't have to do anything else. That means there is no solution. Okay? So again, anytime you're plugging something in and you get a negative number inside of a logarithm, doesn't have to do anything else. Just stop and say no solution. Okay? One more example, then we're going to wrap it up. So we got number 7 here. So we have this. So again, I encourage you to go and pause the video and see if you can do this one by yourself. So condense it, see if you can solve that for x, and then check to see what your solutions are to make sure that they work. So if you do that, if we condense, we got to multiply on the left. And again, if you FOIL or use box method inside of there, we have log base 18 of x squared plus 3x minus 10. So now we have to use the definition. So we set x squared plus 3x minus 10 equal to 18 to the first power, which is just 18. And remember, a long time ago, I said quadratics and factoring and solving weren't going to go away. Wasn't lying to you. So I need to subtract 18 from both sides. We got x squared plus 3x minus 28 equals 0. And then factor that. And then, of course, when we solve both those factors, we have x equals negative 7 and x equals 4. We have two solutions. Got to check them both. So if you plug in the -7 and then simplify the insides, notice we get a negative inside both arguments. That's a no-go. So the -7 is not a solution. That's one of our extraneous solutions. But if you plug in 4, 4 is okay. And that does come out to be correct. So both arguments are positive, so it's okay. So we have x equals 4. Okay, so that is the whole process of being able to solve log equations. Next week, we're going to get into solving exponential equations. It's going to be a similar process, but we'll take a look at that then. I'm going to go and link the video to last week's. There were 2 videos from last week on the basic log properties with the definition, and then also the log rules. So I'll link to those, and they should be popping up right now. And also, again, as always, feel free to subscribe to my channel if you have, so you get notified when we get some new videos posted up. And also, if you have anybody else, if you have some friends of yours that are doing the same kind of thing, feel free to share the video with them. Until next time, again, I hope you guys are staying well and staying healthy and staying inside for the most part. I miss you guys. I look forward to seeing you soon, certainly next year when we come back in August. But until that time, keep studying.